Welcome viewers to the second lecture of sterilization techniques. In our first lecture on sterilization techniques, we discussed about heat and low temperature to control microbial growth. But there are conditions where we need to handle with agents which are heat labile and we need to sterilize them. Then we need to go for some alternative mechanisms. One of the important such alternative mechanism is filtration. It's just a mechanical method wherein the liquid things which are to be sterilized are passed through the membranes and they are collected in sterile containers. Filtration can be of two types. One is membrane filters, second is depth filters. Depth filters are made up of fibrous material which comprises of an array of either papers or of borosilicate fibers. These things are utilized to get rid of particulate matter and they are used precisely in laminar air flows or in cleaning of air in industries, for sterilization of air in industries. It is also used in operation theatres, and the most effective one is called as HEPA filter, which stands for high efficiency particulate air. So these filters are capable of obstructing materials of the size of 0.3 micrometers, and their efficiency is so high that almost 99.9% of compounds are restricted with these filters, right? So we have seen about depth filters, then we come to the membrane filters.
In case of depth filters, if you use in laminar airflow, we get a sterilization of 99.9%, as you said. So if you use this depth filters for the sterilization of room in case of ACs fitted with HEPA filters, can we get this amount of sterilization?
Exactly. You said rightly that if we use this type of HEPA filters in our ACs, then the air that is coming out of the AC is 99.9% free of particulate air. But the thing is, under such circumstances, the room should also be sterilized. These things are done while patients who have been operated with organ transplantation like kidney transplantation or heart transplantation, after that they are kept in the quarantine rooms, right? So it means they should be kept in a sterile room. The rooms are sterilized using UV radiations, we are coming later on, and the air that is coming out of the AC should obviously be treated with HEPA filters, right? So next we will be talking about membrane filters. These membrane filters are basically polymers of polysulfonate acetate, and what is done actually that these filters are kept at certain heights and vacuum pressures are applied, and with the help of that vacuum pressure the liquid that is to be filtered comes out. Right? This method of sterilization is basically used when we want to sterilize certain heat labile materials like antibiotic solutions, ophthalmic solutions, or we may say certain pharmaceutically important compounds. It means this membrane filters are to be used to sterilize only those compounds which are heat labile. And one more additional point is that we can increase or decrease the pore size of membrane filters depending on the concentration of the polymer that we are using for making of the membranes. If we increase the concentration of the polymer, then the pore size will decrease, and if we decrease the polymer concentration, the pore size is going to increase. In this way we can regulate the pore sizes. There are certain heat sensitive commodities which cannot be sterilized by filtration. So we need to go for some alternative methods like radiation. Radiation sterilization can again be of two types. One is called non-ionizing radiation, other is called ionizing radiation. Non-ionizing radiation, example is UV light. Ionizing radiation, examples are X-rays and gamma rays. Now coming to non-ionizing radiation or UV rays. UV rays have a broad range of 100 to 400 nanometers, out of which 254 nanometer light is being absorbed by the microbes. What happens that after absorbing this UV light carries on the dimerization of two adjacent thymidine residues in the DNA. Once this two thymine gets dimerized, or they are tagged together, it prevents the replication of the DNA as well as it prevents the transcription of the DNA to RNA. So the two vital processes that keeps a bacteria viable, that is the replication process and the transcription process, are ruptured, as a result of which bacteria dies off. So this is the mode of action of UV light. These UV lights are actually used in laminar airflows, in sterilization of open airs in operation theatres. It has got versatile uses, but one of the limitations of UV light is its low penetrance, as a result of which only the microbes or contaminants which are present onto the top of the surface or on the top of the air are getting sterilized. But the microbes that are residing beneath Earth's surface are unable to be sterilized. So next comes the ionizing radiation. Ionizing radiation comprises of X-rays and gamma rays. What happens there, that there are electromagnetic radiations. They cause the electrons to come out of their outermost shells, and once these electrons are coming out of the outermost shells, they carry on the ionization of the atoms. Because of this ionization of the atoms, what they do, they interact with the water molecules present inside the bacterial cells. And because of this interaction, there is generation of free radicals as hydroxide radicals, hydrogen radicals, and so on. This leads to disruption of the important macromolecules. These radicals not only destroys proteins, it destroys the nucleic acids. So all the vital nutrients or the vital macromolecules of the microbes are getting disrupted. This is the mode of action of a ionizing radiation. These things are used for sterilization in the food processing industries, and it is used in those places wherein UV rays cannot penetrate. These things are being utilized for sterilizing disposable petri dishes, for sterilizing surgical equipments. So in this manner we may say that ionizing radiation is much more effective as compared to the UV radiations, but it has got certain limitations, as the use of ionizing radiation needs very technically sound hands. It needs very high-end instruments to be used. It is used basically for the sterilization of meat, food products, etc. But there are certain suspicions from people that people think that the food quality is getting destroyed, but the answer is no, the food quality is not getting destroyed. So far we have discussed about various physical agents for sterilization purpose. Now we are coming to the use of chemical agents to combat microbes. Unlike physical agents which go for perfect sterilization, these chemical agents actually are not capable of killing the microbes completely. They are specially interested in removal of pathogenic microbes. So the first chemical agent that we will take up is the halogens. We all know that halogens are present in the group 7A of periodic table. All of them have 7 electrons in their outermost shell. It mainly comprises of fluorine, chlorine, bromine, iodine, and astatine, out of which chlorine and bromine are used as very good disinfectants. So first of all, we will talk about iodine. Iodine is a very good skin disinfectant, as you have always used tincture of iodine during any wounds. What it is comprising of 2% potassium iodide solution in aqueous ethanol mixture. But there are certain limitations or drawbacks of using this potassium iodide solution, that it has got a pungent smell, it produces certain skin eruptions, and it is very much harmful to the skin. To avoid this, what is done, that an organic compound is tagged along with the iodine that we call as iodophore is used nowadays. What is the function of iodophore? That iodophore comprises not only of iodine, but it also contains a detergent part or an organic part. So this organic part actually helps in loosening the microbe from the surface where it is toughly attached. Once the microbe is loosened from the surface where it is toughly attached, then it becomes easier for the iodine to execute its killing action. Now the question arises that how they execute their killing actions. What they do, they carry on iodinization or oxidation of important proteins present in the microbes. Thereby their enzymatic activity is disrupted. So this is how we have discussed the use of iodine as a disinfectant. Next comes chlorine. All of you know that chlorine is used for disinfection of water. Similarly, chlorine has got a similar mode of action. So chlorine is used every now and then for disinfection process and cleaning of water, swimming pools, etc. But the problem with chlorine is that it combines with water molecules to form certain carcinogenic compounds like trichloromethanes.
Ma'am, how can this problem be overcome?
To overcome this problem, we have started using chloramine T, wherein chlorine is combined with ammonia. The result of which is there is slow release of chlorine and its detrimental effects are diminished. Phenol and its derivatives are also used as chemical disinfectants. We have heard of use of phenol during the time of Lister, but the drawback with phenol is its highly toxic nature. That's why different derivatives of phenol are used nowadays as good disinfectants. Hexyl resorcinol is used commonly in disinfection process. Next we have got bisphenols are also used for the disinfection and antiseptic processes. We do have the use of triclosan, which is a very good antibacterial agent to combat the microbes, is being prominently used. Next we are coming to the role of heavy metals in combating the microbes. We have seen the use of mercury, zinc and copper and other heavy metals for combating the microbial growth. Among this, we have seen the role of mercury. We have used mercurochrome in wound healing processes. We have seen the use of silver nitrate solution to combat infections in the eyes. We have seen the involvement of copper as disinfectants.
Ma'am, we have come across a term called oligodynamic action associated with these heavy metals. What do you mean by this?
Actually, oligodynamic action means if any compound can exhibit antimicrobial activity in very smaller concentrations, then we call it as oligodynamic action. Next, we have soaps and detergents for combating microbes. All of us use soaps before taking our meals or handling some microbes, we all know. But soaps have got certain limitations. That's why it's better to go for some harsh treatments when we want to get better response. We go for use of detergents. Most popularly used detergents are quaternary ammonium compounds or quartz, wherein the hydrogen atom present in ammonia or ammonium salt is being replaced by certain organic compounds.
In case of soaps and detergents, as an antimicrobial agent, which one is superior?
Yeah, as an antimicrobial agent, I must say that detergents are much more superior because they have got better efficacy as compared to the soaps. We use detergents like benzoconium chloride for killing of mycobacterial infections as well. Now we are going to discuss about the role of aldehydes in combating microbial load. So aldehydes like formaldehyde and glutaraldehyde are mostly used as sterilizing agents. What they do, they are basically alkylating agents. They intercalate with the nucleic acids and the proteins of the microbes, thereby they execute their killing action. Usually formaldehyde has an irritating effect on skin. That's why glutaraldehyde is preferred over formaldehyde as a sterilizing agent. They are capable of acting as a sporicide. 2% solution of glutaraldehyde is used to combat or kill microbes within 10 minutes. But if we want to remove the spores, then the treatment should be extended till 12 hours. So glutaraldehyde solution can be done in water as well as in alcohol. So it can be used in hospitals for sterilization purposes. Now we are coming to the use of alcohols for sterilization purposes. All of us are very much familiar with the use of rectified spirit whenever we go for some injections or blood suction tests. So it is a local method of removing bacteria by use of alcohols. Usually we think that dehydrated alcohol, that is 98 or 99% alcohol, should be much more effective than the rectified spirit. But the real story is a bit different, that as soon as we add water to the alcohol, its dehydrating ability or ability to evaporate decreases, thereby its retention time is increased. So 70% alcohol is much more effective as compared to dehydrated alcohol. Now the question arises that how they are killing the microbes. What they do, basically they destroy the nucleic acids and the proteins of the microbes, as well as sometimes they dissolve the lipids of the cell membranes.
And what is the major mode of difference between alcohols and aldehydes?
Actually, aldehydes are executing their action by alkylating the proteins, whereas this alcohol is executing its action by denaturing the proteins. This is the basic difference. Now we are going to discuss on the sterilizing role played by various gases. Number one is ethylene oxide. So ethylene oxide is used for the sterilization purpose because of its high penetrance.
On what factors the rate of sterilization by ethylene oxide depends?
It depends mostly on concentration, humidity and temperature. Say for example, at a particular temperature and at a fixed concentration, a definite amount of time is needed for its sterilization. So if these three parameters are altered, then the entire story will change. The drawback with ethylene oxides are there. That's why we started working with BPL or beta propionolactone. Right? Beta propionolactone has also got very good penetrance as compared to ethylene oxide. But the problem with ethylene oxide is that once the sterilization process is done, we need to wait for some time to remove the unused ethylene oxide, as it has got some cancerous effects.
Ma'am, what are the benefits and drawbacks of BPL or beta propionolactone over ethylene oxide as a sterilizing agent?
The benefit of beta propionolactone is it is easier to remove beta propionolactone after the completion of process as compared to ethylene oxide. This is one of the benefits. And regarding the drawback, we can say that the penetrance of ethylene oxide is much better as compared to the penetrance power of BPL.
Okay.
Right? Apart from these two, we can use vaporized hydrogen peroxide also for the process of sterilization, right? So hydrogen peroxides is being used to carry on the sterilization process. It is harmless, and they can be used in a wide range of temperature, say from 4 to 80 degrees centigrades. These are the basic benefits of using hydrogen peroxide as a sterilizing agent. They are used mostly in biological safety cabinets and operation theatres. It is toxic and has got some hazardous roles too, so we need to take care of those things into account.
Ma'am, how the effectiveness of antiseptics and disinfectants be determined?
Yeah, we do have methods for measuring the effectiveness of antiseptics and disinfectants. The popular method is called as phenol coefficient. Herein what we do, that we use different concentrations of phenols, and some standard microbes are utilized, and the time needed for killing of the microbes using different concentration of the phenol and the different concentration of the test disinfectants are compared. And if this phenol coefficient value is greater than 1, it means that the agent is a better disinfectant than phenol, and if the phenol coefficient value is less than 1, then we may say that it is a worse or bad disinfectant as compared to phenol. Here the standard organisms that are used are Staphylococcus aureus, and these organisms are tested for their ability to be killed within 10 minutes but not less than 5 minutes. Means the duration of time that is needed to kill the organism should be lying within 5 to 10 minutes. The concentration at which the organisms are killed within this duration of time is noted down, and it is compared with the concentration of phenol that is doing the same work in same time. In this way these things can be compared, but this has got certain disadvantages because we are comparing this data in a lab inside the test tubes, but we never know that what will be their real role when they are being applied in their original fields. Say for example, I have said in my first lecture that environment has got a vital role to play. If the environment is supporting the growth of the microbes, then this titer that we have determined inside the lab will be not tallying with the real field data. Right? So these are the drawbacks of phenol coefficient, but still we can get an idea whether this can be a disinfectant, good disinfectant or bad disinfectant. This type of idea at least we can get from there. So in our lecture on sterilization in techniques, we have gone through different physical agents and different chemical agents and their efficacies, their mode of actions, their capability to kill the microbes. Some of them are good disinfectants, some of them are antiseptics, some of them have sporicidal activities. We have gone through it.